really quite worthwhile. So before I introduce my speakers, let me tell you a little bit about the state of CITRIS. So I'm Shankar. I'm the current director of CITRIS. There are many, many friends of CITRIS in this room besides those that we acknowledged. And it was great to see Dan Pitt asking a question. I know Dan and Dave Tenenhouse have spent so much time getting it. I want to recognize my predecessor, Rujna Baichi, who was the founding director, and Jim Demmel, who was the first chief scientist. So a lot of them did the heavy lifting, and I only sort of came in after it was all going. So this is it's a partnership with 4 campuses. It's Davis, Berkeley, Merced, and Santa Cruz. And this sort of planetary representation is geographically accurate, anyhow, in terms of where they are in the state of California. Our job, as we decided on the panel, was to keep this technology pipeline full, to get a savvy workforce, and the other parts are that concomitant with this, which what Dave called the desire in America to make money, is creating jobs through harvesting the best economies. And the last part is really to create this ecosystem. The ecosystem that we talked about at Bell Labs and IBM and so on and so forth, it's an ecosystem which is truly international in addition to, so it has governmental stakeholders, venture, industry, academia, and so on and so forth. So that's sort of our mission statement. And from the beginning, we've really sort of thought about societal problems first. And these are the set of societal problems that we've always focused on. Energy, education, transportation, IT for emerging regions, which you'll hear about in Eric's talk, the environment, both monitoring as well as being more activist about it, emergency response, homeland security, it's perhaps another way of thinking about it, and finally healthcare. This is information and communication technologies for the better delivery of healthcare and service sciences. I'll tell you a little bit more about these two during this talk. So it's been just a really wonderful partnership between these 4 UC campuses. As Dick Blum said, it's 1 university, 10 campuses. So this is our Northern California 4 campuses. It's and these are what the CITRIS affiliated buildings look like. The Merced building, which is actually a brand new building, Santa Cruz, Davis, and of course Berkeley. We just had a hole in the ground, so we have a picture of the. And I wanted to say that there was significant funding from the state of California for doing this, but really a lot of the support has come from private donors and very substantial gifts, and from industry. Just to give you a sense of this, when we started off with a certain number of founding corporate members. Over time, this has grown a little bit into platinum corporate members and associate corporate members. They're all over the world. These are the stars show where they are. And there are 31 of them. Additionally, 60 other companies. So these are rather substantive commitments in terms of the level of support. 60 companies in addition to that. Also, as I'll describe to you in a second, the operating model of CITRIS is to be an umbrella for a bunch of different centers. And there are separate industrial sponsorships of those centers. So our job, the way we think about it, is we help initiate these research centers because we feel that that's where the sweet spot is. And the sweet spot is in the form of these groups, 5 to 8 faculty, 50 to 80 graduate students. And in addition, when we've announced them, we almost always announce them, and there's been one large federal sponsor of about $1 million or more, and then 2 or 3 corporate sponsors, and then perhaps a few other sponsors thrown into it. And the life of one of these centers, we think, is about 5 to 8 years, even though sometimes the agenda can go on longer than that. So just in the last 5 years, we've created over 20 of these. And these are the names of some of the centers, and they're all over. They're at Berkeley, Santa Cruz, Davis, Merced. There's a Merced Water Initiative. There is a Davis-led optical networking center. And by and large, they have always had this model of large federal grant and then offered as leverage to our industrial sponsors. Except recently, 2 examples of how the landscape may be changing. The Chancellor and Beth just alluded to this BP-led initiative, which may be an exemplar of how things are changing, where it's really a corporate-led initiative. And my colleague Dave Patterson has put together an initiative called the RAD Lab, that's all the way at the bottom on the right, where the sense has been that it's really underwritten primarily by industry. Of course, the $169 billion of profits is perhaps a sector of the industry that can sustain this a lot better than the IT industry, even though the IT industry, of course, is doing well. Just to give you a sense of some of the recently announced centers, and I've tried to get some from all the campuses, and they are pretty diverse. A lot of them on this slide have to do with energy and the environment. There's a aerosol health effects center at UC Davis. That's Governor Schwarzenegger with the Davis Chancellor at the Energy Efficiency Center. It's hydrogen economies. Prime is a Berkeley center which is dedicated to the fact it's really a project in collaborative science. Different people have work on different parts of combustion. For instance, they're thinking about methane combustion, and the idea is they work on different bits and pieces, and even though science is supposed to be falsifiable, they have so many different sort of snapshots of this process of methane combustion that there's no real agreement, there's no way to put this all together, and Prime is a way of trying to figure out how to do collaborative science. You know, we all talk about being deluged by mountains of papers and not being able to compare one against the other, and that's sort of the broader agenda. A lot of projects on water and the usage of water, starting from the Sierra snowpack to its utilization in California. So the four strategic directions have been energy and the environment, and that's joint with the project that the Chancellor talked about, Helios, which is headquartered at the Lawrence Berkeley National Labs. Intelligent infrastructures. So as David said, you know, people think of infrastructures as boring, but really, and I'll say with immigrant zeal too, I think the strength of this nation has been, the strength of California has been a strong infrastructure on which you can build a robust economy. And when the infrastructure sags, you've got to get the best technology into our infrastructures. And once you get the best technologies, I think there's a business case to be made for it. I'll say something about service sciences and technology, but roughly speaking, this is the notion of how high-wage regions can still build intelligent services and make a profit in the face of technology that's being increasingly commoditized. And finally, the last area is the use of information technology for better delivery of healthcare. Now, an exemplar of where I think in the last 4 or 5 years we've actually had a lot of success, and it's with partners in industry. There's some pictures here from Intel. This is Intel instrumenting Great Duck Island off the coast of Maine. But there are lots of pictures here about the fact that these wireless sensor networks, we can basically instrument the world. You know, redwood trees, firefighting, Paul writes firefighting, the Golden Gate Bridge, factories, outdoor firefighting, Nick Satar, and a whole host of other applications. And these last two applications refer to the process control industry, the chemical industry, the oil and gas pipelines. The infrastructure for controlling them is already becoming these wireless sensor networks. So last year, the prediction, so this is technology that really started in 2000, 99, 2000 maybe. But today, analysts' estimate of the size of this market is 60 to 80 billion. So last year it was 20 billion, but it really, since there has been such a large set of applications, especially in this process control industry, there's several large companies, Honeywell, Emerson, etc., which are all sort of now struggling with the standards required to move forward with this. One other example, which is closer to home, which shows the partnership with the state, is that we worked with PG&E and the California Energy Commission to try to get this technology into homes. So you all know that and you'll see a lot more of this in Paul Wright's talk, which is to follow. But the notion is that if you can have these wireless sensor networks, you can start instrumenting homes to be able to turn devices on and off or control their consumption in response to pricing signals. The pricing signals are what has been, the PG&E has put into place, and that's 1 million households in July 2006, whereas the micro-mote that we'll use for instrumenting the inside of homes is what is going to come out of this technology. So this is stuff that's not just pie in the sky, it's really stuff that's showing up. Now, let me just, in my remaining few minutes, just tell you a little bit about what we're doing in services and what we're doing in healthcare. So this is a picture, and I'm sure a lot of you see these pictures. They're in The Economist and so on and so forth. They show the fact that A is the agricultural sector, G is goods, and S is services, even in even in countries like India, China, Brazil. The fraction of the workforce that's moving into services is growing dramatically. Now, we think that we need to try to teach our students about how do you deliver services. If hardware is going to be commoditized and software is going to be written offshore, the question about how do you put together services is an important one. Also, when you take a look at some recent successes, Google, eBay, iPod, these are all examples of the success of services on top of commodity technology. So the question is, how can we teach our students, and they're all based on the fact that information and communication technologies are really changing the nature of how we deliver services. The question we've set ourselves to ask is how we try to do this. So one of the first things we've done, and this was related to the talk about the educational mission, is we think that there's a sweet spot to try to offer a certificate program, sort of like a master's, in service sciences, management, and engineering. And the kinds of, and here's a little bit about what we're doing in Santa Cruz and Berkeley. We will probably be doing more at Davis and Merced as well. And the research opportunities that go on with them are in some key service areas. Let me talk to you a little bit about what the service problems are in the area of healthcare. To talk about healthcare, we all have seen, again, we all are aware of the magnitude of this problem. It's between 15 and 16% of our GDP. It's the fastest growing sector of the economy, growing 7%. And in the industrialized world, the U.S. is the fastest growing, the cost of healthcare is the fastest growing in the industrialized world. Of course, if you believe the 7% number, then in a few years the entire economy will be just healthcare. So you wonder about these sustained growth numbers. On the other hand, what is true also is that the percentage of population over the age of 65 is also growing. And the question is, can you use information communication technology to better deliver healthcare? And the answers are that there's a huge amount of new technology that's showing up. So telemedicine, this particular set of pictures is telesurgery. And the next one is that we've really finally got, as of February 2005, legislation that supports personal electronic medical records. And so these are examples of what you can do. So why are all these important? So for instance, of this $2 trillion, 30% of it is spent in lab tests. That's $600 billion. Of that, 70% is in moving paperwork around. So that's $400 billion. And we all know that your pathology tests are never in the right place. So even though we spend $400 billion, it's because the records are simply not moving. If you can own your own electronic medical records and sort of have an ontology, have a tree structure for being able to search through data, you might be able to do a lot better. And that's the sort of technology piece that goes along with this delivery. So here, and we're doing this jointly with Reg Kelly's Institute QB3, which is another one of these, and three things that we're doing, sort of this pre-symptomatic sensing of diseases using low sample sizes, but then use of wireless portals for, rather than having a pull model, which is a doctor says you should have such and such a test, especially for chronic conditions, have a push model of continuous monitoring. And finally, even though this may seem like electronic medical records may seem like a techie thing where you own your record rather than the hospital, it creates a huge sea change of who has access to what, an audit of these electronic medical records. So again, the play between security and privacy, high confidence medical devices. If there's all these computer chips in medical devices monitoring yourself, and in hospitals, what if a hacker wants to attack them? And how do you sort of guard against this? Those are the kinds of questions that we're looking at. So, in conclusion, I would like to say that people use this term public-private partnership (PPP) quite often in and almost in throwaway fashion. But I have to say that CITRIS really has been this PPP, this public-private partnership, really harnessing the best of private giving, state support, federal support, and I really hope that it will be a transition bridge between academia and industry for solving the strongest problem, the most pressing problems that society will have. So, to see more, we have a website where, at the price of trying to negotiate this website, you can find a lot of information. We're trying to work on making it easier still. So, thank you very much for all your support, and I will segue right away into the second piece of this. So, this was a little bit of an overview of CITRIS. What I now want to do is to present two of my colleagues who will work through the details of two important research items, two research thrusts. The first one is the chief scientist for CITRIS, Paul Wright. And Paul will talk to us about the energy challenge and what we are doing in CITRIS on energy. So let me welcome to the stage Paul.